In 2019, a woman I'll call Anna was dying of Alzheimer's. She'd been in the final stages for years. She hadn't recognized her children in months. She couldn't speak. She couldn't feed herself. She couldn't hold a spoon. Her brain was, by every medical measure, destroyed. Riddled with amyloid plaques, shrunken, large sections of cortex effectively dead tissue. The neurologists had been clear. The Anna her family once knew was gone. Her brain could no longer produce her. And then, about 36 hours before she died, Anna sat up in bed. She looked at her daughter. She called her by name, and she said, "I love you. I'm sorry I've been away." They talked for almost 2 hours. Anna asked about her grandchildren. She remembered names, birthdays, details from decades ago. She laughed. She made a joke about the hospital food. She was funny. She was sharp. She was, unmistakably, completely herself. And then she fell asleep, and she died. Neurologists call this terminal lucidity, and it isn't rare. It happens in roughly 5 to 20% of deaths from dementia, depending on the study and who's counting. Families have been reporting it for centuries. Doctors have been quietly noting it in charts. But science has never been able to explain it. Because here's the problem, and I need you to really sit with this. If consciousness is produced by the brain the way a factory produces cars, then a destroyed factory cannot suddenly produce a perfect car. A brain eaten by Alzheimer's, physically, structurally devastated, cannot suddenly generate the most lucid conversation of a person's life. It would be like smashing a television into 100 pieces, and then watching it play one last, perfect, crystal clear broadcast. Unless the television was never generating the picture in the first place. Unless the relationship between your brain and your mind is something fundamentally different from what science has assumed for 400 years. This video is about a question that science has tried to kill, bury, and forget, and that keeps clawing its way back up. A question that, as of right now, in 2026, is more scientifically alive than it has been in centuries. The question is simple. The answer is anything but. Do you have a soul? Now, before you click away thinking this is going to be some kind of spiritual sermon, let me be very clear about what this video is and what it isn't. I'm not a priest. I'm not a mystic. I'm not going to tell you about angels or past lives or the healing power of crystals. What I am is someone who read a book earlier this year that genuinely unsettled me. Several books, actually. And when I started pulling at the thread, what I found was that the most rigorous scientists and philosophers alive, people at CERN, at NYU, at major research hospitals, are having a conversation about consciousness right now that would have been career suicide 10 years ago. The ground has shifted. And I don't think most people realize how much. The book that started me down this particular rabbit hole is called A World Appears, A Journey into Consciousness by Michael Pollan. Yes, that Michael Pollan, the food guy, the psychedelics guy. Published in February 2026, already a New York Times bestseller. Pollan spent years tracing what he calls the unmapped continent of consciousness, meeting neuroscientists, philosophers, plant biologists, AI researchers, people who study psychedelics, people who study the dying. The book is organized beautifully. It starts with the most basic question. What is sentience? Can a plant feel? And escalates all the way up to the nature of the self. The Atlantic called his ability to scent the direction the culture is heading genius. The word is not too strong. But Pollan's book is the door I walked through. What I found on the other side draws from about a dozen other sources. Sabine Hossenfelder's Existential Physics, Philip Goff's Galileo's Error, the work of a man named Bernardo Kastrup, who is possibly the most interesting thinker most people have never heard of, and a relatively new scientific study of terminal lucidity by a researcher named Alexander Batthyány that may be the single most important dataset in the history of consciousness research. I'll get to all of them, but first we need to start with something simple. Something so obvious you've probably never thought about it carefully. You are a bag of atoms. I mean this literally. If you weigh about 70 kilograms, roughly 154 pounds, you are made of about 7 octillion atoms. That's a 7 followed by 27 zeros. And the ingredients are almost comically ordinary. Oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, a bit of potassium, a trace of iron. If you were to buy these elements at industrial prices, you, all of you, the whole magnificent, feeling, dreaming, complicated you, would cost about $1, maybe $5 if you adjust for inflation. Now here's the first strange thing. Those atoms, they're not yours, not in any permanent sense. Your body replaces virtually all of them on a rolling basis. Paul Ebersold at the Mayo Clinic demonstrated this with radioisotope tracking as early as 1954. Roughly 98% of the atoms in your body are replaced every single year. Your stomach lining replaces itself every few days. Your skin is entirely new every 2 to 3 weeks. Even your skeleton, which feels so solid, so structural, so you, is completely swapped out about every 10 years. The atoms that make up your body right now are not the atoms that made up your body a decade ago. Not a single one. So think about what that means. If you are your atoms, then you've already died. Many times. The physical stuff of you has been completely replaced, over and over, like a river that keeps flowing, while the riverbed stays the same shape. The Greeks had a name for this puzzle, the ship of Theseus. If you replace every plank of a ship, one by one, is it still the same ship? It's a great thought experiment, but here's what I didn't fully appreciate until I read Hossenfelder's book. It isn't a thought experiment. It's your actual biology. It's happening to you right now. You are the ship of Theseus. Every day, every hour. And yet, you persist. You remember your childhood. You recognize your face in the mirror. You feel continuous. You feel like you. What exactly is this you? If you'd asked a physicist this question 400 years ago, well, you wouldn't have, because the word physicist didn't exist yet. But if you'd asked a natural philosopher, they would have had a ready answer. You have a soul, an immaterial substance. Descartes called it res cogitans, the thinking thing, that exists alongside the physical body, but is not made of physical stuff. Your body is a machine. Your soul is the driver. If you ask a physicist this question today, the official answer is very different. The official answer is, there is no you above and beyond your atoms. You are what your atoms do. Consciousness, the feeling of being you, is something the brain produces, the way a kidney produces urine, or a stomach produces acid. It's a biological function. A very complicated one, sure, but ultimately, in principle, reducible to physics and chemistry. This view is called physicalism, or materialism, and for most of the 20th century, it was the only view a respectable scientist could hold. To question it was to risk your career. To suggest otherwise was to be branded a mystic, a crank, a throwback. But here's what I want you to remember, because I'll come back to this. Remember this moment. The official view is that consciousness is produced by the brain. Keep that in your pocket, we're going to need it later. Because first, I need to tell you about Galileo, and the 400-year-old mistake that made modern science possible, and possibly broke it forever. In 1623, Galileo Galilei did something extraordinary. It's not what you think. I'm not talking about dropping balls off the Tower of Pisa or pointing a telescope at Jupiter. I'm talking about something much more profound and much more consequential for the question of whether you have a soul. In 1623, Galileo published a book called The Essayer, and in it he made a declaration that would change the trajectory of human civilization. He declared that from now on, the language of science would be mathematics, pure quantities, numbers, measurements, size, shape, location, motion. These were the properties of the real physical world. These were what science would study. But notice what got left out: color, taste, smell, sound, the warmth of the sun on your face, the ache you feel when someone you love is suffering, the redness of red. All the qualities of experience, everything that makes it feel like something to be alive. Galileo explicitly moved those out of the physical world and into the soul. He said these qualities don't really exist in the objects themselves. They exist in the perceiver. The lemon isn't actually yellow. Your mind makes it yellow. The rose doesn't actually smell sweet. Your mind constructs the sweetness. This was Galileo's deal with the devil, and it worked. It worked brilliantly. By stripping all subjective qualities out of the physical world, Galileo gave us a world we could measure, a world we could mathematize, a world we could build equations about. And from those equations came everything: Newton's laws, electromagnetism, thermodynamics, quantum mechanics, rockets, antibiotics, smartphones. The entire edifice of modern science and technology was built on Galileo's move. The philosopher Philip Goff at Durham University in England wrote an entire book about this called Galileo's Error, and his argument is devastating. The reason science can't explain consciousness isn't that it hasn't gotten around to it yet. It's that science was explicitly designed from the very beginning, 400 years ago, to exclude consciousness from its domain. The hard problem of consciousness isn't a gap in our knowledge. It's a hole we deliberately drilled into the foundations of the building. And now we're living in the building, looking at the hole, and wondering why there's a draft. Sounds like nonsense, I know. Let me make it more concrete. Imagine a neuroscientist, the best neuroscientist who ever lived. She has a brain scanner so powerful it can track every single neuron in your brain, every synapse, every electrical impulse, every molecular interaction, all in real time. She knows everything, literally everything, about the physical state of your brain at any given moment. She can tell you which neurons are firing when you see the color red. She can predict to the millisecond when you'll feel a twinge of sadness. She can map every chemical cascade that accompanies your experience of falling in love. But here's the question: can she tell you what red looks like? Not which neurons fire. She already knows that. I mean, can she know the experience of red? The redness. If she'd been blind from birth, if she'd never once experienced the color red, could all that neuroscience, all that perfect information about brain states, give her that experience? The answer, and this is not controversial among philosophers, this is something even committed materialists generally concede, is no. She would know everything about the physical process, and she would still not know what red looks like. There is something about subjective experience that isn't captured in the objective physical description. This is what the philosopher Thomas Nagel was getting at in 1974 when he asked, "What is it like to be a bat?" You can know everything about bat sonar, the frequency of the sound waves, the neural processing, the behavioral outputs, and you still won't know what it feels like to experience the world through echolocation. What it feels like, that's the hard problem. And it has been the hard problem for a very long time, longer than you'd think. In 1714, Gottfried Wilhelm Leibniz imagined a thought experiment. Suppose you could shrink yourself down and walk inside a brain the way you'd walk inside a mill. You'd see gears turning, mechanisms clicking, parts moving. But no matter how carefully you looked, you would never see a thought. You would never see a feeling. You'd see the machinery. You'd never find the experience. 150 years later, Thomas Henry Huxley, Darwin's most fierce defender, a man who had zero patience for mysticism, wrote that the appearance of consciousness from brain activity is just as mysterious as the appearance of the jinn when Aladdin rubbed his lamp. And then, in 1995, David Chalmers, an Australian philosopher with rock star hair and a very serious mind, gave the problem a name. He called it the hard problem of consciousness. And he drew a line that has never been erased. Explaining which brain processes correlate with consciousness is the easy problem. Not easy in practice, just easy in principle. It's the kind of problem that more data, more scanning, more computing power might solve. The hard problem is explaining why any of this neural activity is accompanied by subjective experience at all. Why isn't it all just information processing in the dark? Why is there a light on inside? Pay close attention to this next part, because it tells you something important about where we stand. In 1998, the neuroscientist Christoph Koch made a bet with David Chalmers. Koch was working closely with Francis Crick, yes, the DNA guy, and they were both convinced that consciousness would yield to standard neuroscience. Koch bet Chalmers a case of fine wine that within 25 years, by 2023, researchers would discover the neural mechanism of consciousness, the physical signature, the thing that makes the lights come on. 25 years passed. Brain scanning technology advanced beyond anything Koch could have imagined in 1998. Functional MRI, high-density EEG, optogenetics, whole brain connectomics, billions of dollars in research funding, thousands of papers published. And in June of 2023, at the annual meeting of the Association for the Scientific Study of Consciousness in New York, Koch walked onto the stage and handed Chalmers a case of wine. He'd lost. It wasn't even close. Not only had the mechanism not been discovered, the two leading theories of consciousness that were tested in a collaborative experiment had both failed to make the predictions they needed to make. Science was not incrementally closer to bridging the gap. Some researchers openly wondered whether it had been asking the right question. Koch and Chalmers doubled down. They made another bet. Same terms, another 25 years. 2048. I'll be quite old by then. I hope I'm around to see who wins. But here's the thing that should bother you. It's been 400 years since Galileo. It's been 300 since Leibniz walked into his imaginary mill. We have the most powerful tools for studying the brain in human history. And we are, by essentially any honest assessment, no closer to understanding why there is a you watching the neurons fire than Leibniz was in 1714. Unless And this is where it starts to get genuinely unsettling. We've been looking at the problem from the wrong direction entirely. Let's go back to the dying. Alexander Batthyány is a professor of theoretical psychology in Vienna and Liechtenstein. For years, he has been quietly collecting and systematizing something that the medical profession had mostly treated as anecdotal curiosity: cases of terminal lucidity. People with severe dementia, people whose brains were, by every objective measure, incapable of producing coherent thought, suddenly becoming fully lucid in the hours or days before death. His work, published with Bruce Grayson in Psychology of Consciousness in 2021, was one of the first systematic academic studies. And what he found was striking. This isn't a once-in-a-blue-moon miracle. It's a pattern. His data suggested that a significant minority of dementia patients experience it. Some for minutes, some for hours. Some, and these are the cases that really get under your skin, for an entire day. Full personality, full memory, full verbal fluency. In brains where the physical substrate for all of those things had been measured, scanned, and confirmed to be severely damaged or absent. Now, I want to be fair here. I want to steelman the skeptical position, because it's the position most neuroscientists still hold, and it's not a stupid position. The skeptical explanation goes something like this. We don't fully understand the brain's resilience and redundancy. Maybe there are neural pathways we haven't mapped. Maybe the brain has a capacity for temporary bypasses, like traffic rerouting around a closed highway, that can briefly restore function even in severely damaged tissue. There's a 2024 study suggesting that fluctuations in amyloid beta oligomerization might temporarily clear enough neural noise to allow fleeting cognitive recovery. It's not magic, it's just biology we don't understand yet. And that's a fair response. I take it seriously. But here's what makes me uneasy. If it were just terminal lucidity, I could file it under biology is complicated and move on. But it's not just terminal lucidity. In 2023, a team at the University of Michigan, led by Jimo Borjigin, published a study in the Proceedings of the National Academy of Sciences that made international headlines. They'd been monitoring the brains of patients in intensive care, patients who were comatose, unresponsive, and ultimately determined to be beyond medical help. When life support was withdrawn, EEG monitors were still running. And in 2 of the 4 patients, as their hearts stopped, as their brains were losing oxygen, as they were dying, the monitors recorded a massive surge of organized gamma wave activity. Gamma waves, the fastest oscillations the brain produces, are the very same brain waves most strongly associated with conscious awareness in healthy people. And this surge didn't happen everywhere. It happened in what consciousness researchers call the hot zone, the junction between the temporal, parietal, and occipital lobes at the back of the brain. The exact area correlated with dreaming, visual hallucinations, and altered states of consciousness in other studies. Let me say that again. As the brain was shutting down, as the machinery was failing, as the factory was going dark, there was a surge of the specific kind of organized electrical activity associated with the highest states of conscious awareness. George Masur, the founding director of the Michigan Center for Consciousness Science, called it a neuroscientific paradox. And that's a very measured, very careful word. But I think what he meant was, this doesn't make sense. Not if the brain generates consciousness the way we think it does. Not if consciousness is what the brain does. I'll give you a few seconds to let that sink in. Okay, so here's where I need to introduce an analogy that might sound mystical, but is actually quite precise. And I need you to hold your skepticism in check for about 3 minutes, because the person who formalized this idea is not a guru. He's a computer scientist from CERN. In 1954, Aldous Huxley, the novelist, the man who wrote Brave New World, published a small book called The Doors of Perception. It was about his experiences with mescaline, but buried in it was an idea that Huxley borrowed from the philosopher Henri Bergson and from William James, the father of American psychology. The idea was this: what if the brain doesn't generate consciousness? What if, instead, the brain filters it? The metaphor is a radio. Your radio doesn't generate the music. The music, the signal, is already out there in the electromagnetic spectrum, flooding the room whether the radio is on or not. What the radio does is tune, select, and channel a particular frequency into something you can hear. If you smash the radio, the music doesn't cease to exist. You just can't hear it anymore. Now, I know what you're thinking. This sounds like New Age word salad. I thought the same thing when I first encountered it. It sounds like something someone says right before they try to sell you a healing crystal. But bear with me here, because the person who has taken this intuition and turned it into a rigorous philosophical framework is not selling crystals. Bernardo Kastrup holds 2 PhDs, one in computer engineering, specializing in artificial intelligence and reconfigurable computing, and one in philosophy, focusing on ontology and philosophy of mind. He worked as a researcher at CERN, the European Organization for Nuclear Research, the place that found the Higgs boson. He co-founded a parallel processing company that was acquired by Intel. He worked as a technology strategist at ASML, which is arguably the most important technology company most people have never heard of. They make the machines that make the chips that make everything. This is not a mystic. This is someone who has spent 30 years in the hardest, most empirical, most technically demanding environments on Earth, and who has concluded, through logic, not faith, that the mainstream scientific picture of consciousness is wrong. Kastrup's position is called analytic idealism, and the core claim is breathtaking in its simplicity and terrifying in its implications. The claim is this: consciousness is not produced by matter. Consciousness is all there is. What we call the physical world, atoms, molecules, brains, stars, galaxies, is what consciousness looks like from the outside. It's the external appearance of inner experience. Your brain is not a generator of your mind. Your brain is what your mind looks like when observed by another mind. I know how that sounds. Let me make it more concrete. Imagine you're looking at a brain scan. You see neurons firing in a particular pattern. That pattern is correlated with the person reporting that they see red. Now, the standard interpretation is the neurons firing cause the experience of red. The brain produces consciousness. But Kastrup points out that there's another interpretation, one that is equally consistent with all the data. The experience of seeing red and the neurons firing are the same event, seen from 2 different perspectives. The experience is what it's like from the inside. The brain scan is what it looks like from the outside. Neither one causes the other. They're 2 views of one reality. And what is that one reality? Consciousness, experience, subjectivity itself. Not your individual consciousness, something vaster, something that Kastrup calls mind at large. And your individual mind, your sense of being you, with your memories and personality and quirks, is what happens when a portion of this universal consciousness becomes dissociated from the whole. Your brain doesn't generate your mind. Your brain is the boundary of your mind. It's the mechanism by which a segment of universal consciousness gets walled off into the experience of being a particular person in a particular body. Kastrup's most provocative analogy comes from clinical psychology. Dissociative identity disorder, what used to be called multiple personality disorder, is a condition where one mind fragments into multiple, apparently separate selves. Each alter has its own memories, personality, sometimes even its own physiological responses, but they're all happening within one brain. One mind, many selves. Kastrup's argument is the universe works the same way. One consciousness, dissociated into billions of apparently separate experiencers. You. Me. Your cat. Maybe, and this is where it really gets wild, the tree outside your window. And here's the thing that stops me from dismissing this as philosophy gone mad. If Kastrup is right, then terminal lucidity makes perfect sense. Death isn't the extinction of consciousness. It's the end of the dissociation. The boundary dissolves. And just before it dissolves, just before the filter fails completely, the full signal comes flooding through. One last, brilliant, perfect broadcast. Not because the broken TV suddenly fixed itself, but because the TV was never generating the picture. Now, you might stop me here. You might say, this is beautiful, but it's not science. Where's the evidence? Where are the equations? What does this predict that physicalism doesn't? And that's a legitimate objection. It's the right objection. So let me take you somewhere you might not expect. Let me take you to the world of plants. Michael Pollan, remember the book that started all of this, devotes a significant portion of A World Appears to what he calls plant neurobiologists. These are researchers studying something uncomfortable. Plants appear to solve problems. Not metaphorically, not as a flowery way of describing chemical reactions. They demonstrate behavior that, in an animal, we would call decision-making. They communicate with each other through chemical signals, and, some researchers believe, through underground fungal networks. They allocate resources strategically. They learn. A 2014 study showed that Mimosa pudica, the sensitive plant that folds its leaves when touched, could learn to stop responding to a stimulus that wasn't actually harmful, and could remember this lesson for weeks. Plants have no neurons. They have no brain. They have no nervous system. And yet they exhibit behavior that functionally looks like cognition. Now, the mainstream interpretation is that this is all explicable through biochemistry. No consciousness required. Fair enough, but then you have to answer, where do you draw the line? How complex does the biochemistry have to get before consciousness switches on? Is there a threshold? A magic number of neurons? And if so, why? In April 2024, something unprecedented happened. A group of prominent scientists and philosophers gathered at New York University and signed what became known as the New York Declaration on Animal Consciousness. Among the signatories, neuroscientist Anil Seth, neuroscientist Christoph Koch, philosopher David Chalmers. The declaration stated that there is strong scientific evidence for conscious experience in all mammals and birds, and a realistic possibility of consciousness in all vertebrates, plus cephalopods, crustaceans, and insects. Insects. We're talking about bees, wasps, possibly ants. In 2022, researchers at Queen Mary University of London observed bumblebees playing with small wooden balls, pushing them around, rolling them, apparently for fun. Not for food, not for mating, for play. If a bumblebee can play, if there is something it is like to be a bee rolling a ball, then consciousness is not a late, sophisticated add-on that evolution bolted onto complex brains. It's something much more fundamental, something that might go all the way down. And this is where we meet Giulio Tononi. Tononi is a neuroscientist at the University of Wisconsin-Madison, and he has spent his career trying to do something audacious: mathematize consciousness. His framework is called Integrated Information Theory, or IIT. And the core idea is this: any system that integrates information in a certain way, a way he quantifies with a value called phi, has some degree of conscious experience. A human brain has very high phi. A thermostat has some. An electron might have a vanishingly small amount. But the number is never exactly 0. If IIT is right, and I should say it's hugely controversial, and the adversarial tests in 2023 were inconclusive, but if it's even approximately right, then consciousness isn't something brains invented. Brains merely amplify something that was already there, something woven into the fabric of reality itself. Sounds insane, right? And yet, and this is the part that made me put the book down and stare at the ceiling, this is exactly what some of the most prominent physicists of the 20th century believed. Arthur Eddington, the man who confirmed Einstein's general relativity, wrote in 1928 that the stuff of the world is mind stuff. Erwin Schrödinger, the man with the cat, one of the founders of quantum mechanics, wrote that consciousness is a singular of which the plural is unknown. There is only one consciousness, he said. What seems like a multiplicity of selves is an illusion. You might not have noticed, but we just crossed a line. We started this video asking whether you have a soul. We've now arrived at a place where serious scientists, Nobel laureates, researchers at the most elite institutions on Earth, are suggesting that consciousness might not be something your brain produces. It might be something your brain receives, or restricts, or carves out from something larger. But here's where it gets really interesting, because there's one more piece of this puzzle, and it comes from a place you wouldn't expect: the philosophy of physics itself. Let me take you back to Sabine Hossenfelder. She's a theoretical physicist based in Munich, and she wrote a book called Existential Physics that I've talked about before on this channel. One of the key ideas in her book, one that she treats with great care because she's a physicalist herself, she's not trying to prove the soul exists, is the concept of strong emergence. Here's the idea. In most of science, when complex things happen, they can in principle be explained by their parts. Water flows downhill because of how its molecules interact with gravity. A hurricane forms because of how heat, moisture, and air pressure work together. This is called weak emergence. The complex behavior of the whole is surprising, but ultimately derivable from the behavior of the parts if you knew enough about them. Strong emergence is different. Strong emergence is when genuinely new properties arise at a higher level. Properties that cannot, even in principle, be predicted from or reduced to the behavior of the parts. Not because of our ignorance, but because something genuinely new has come into existence. Something that wasn't there before. Something that isn't just a rearrangement of what was already there. Science has never definitively confirmed a case of strong emergence. It's one of those ideas that makes most physicists nervous, because it would mean that the reductionist program, The idea that you can explain everything by breaking it down into smaller and smaller pieces has a boundary, a point beyond which breaking things down gives you less, not more. But consciousness is the single most plausible candidate for strong emergence that exists. Because here's what we've established. You can know everything about the atoms. You can know everything about the neurons. You can know every single physical fact about the brain. And you still don't have the experience. You still don't have the redness of red. You still don't have the ache of grief or the warmth of love. There's something, let's just call it something for now, that is not captured in the parts. If strong emergence is real, then the Nobel Prize-winning physicist Philip Warren Anderson's famous line applies. More is different. And what that would mean is extraordinary. It would mean that your consciousness, that you that persists even though your atoms are replaced, that you that watches the neurons fire, that you that is watching this video right now, would be a genuine addition to the universe. Not merely a rearrangement of existing matter and energy. Something ontologically new. Something as real as gravity. Something that, yes, you could call a soul, if you wanted to use that word, without being unscientific. And this is the point in the video where the ground shifts. Because I've been framing this as a question about you, about whether you have a soul, about whether there's something more to you than your atoms. But that's not actually what this is about. What this is really about is whether science, the most powerful tool humanity has ever created for understanding reality, has a blind spot, and whether that blind spot is precisely the thing that's using the tool. Let me explain what I mean. Stephen Hawking once asked a question that almost nobody talks about. He asked, "What breathes fire into the equations?" Physics gives us equations, beautiful equations, equations that describe, with extraordinary precision, how matter and energy behave. F equals ma, E equals mc squared, the Schrödinger equation, the Einstein field equations. These are the finest achievements of human intelligence. They tell us exactly what matter does, but they don't tell us what matter is. Tim Palmer, a physicist at Oxford, puts it this way, and I'm drawing here from Hossenfelder's book. Mathematics describes the behavior of reality, but it does not describe the nature of reality. An equation can tell you that a particle will be at a certain position at a certain time. It cannot tell you what the particle is made of. Not at the deepest level. At the deepest level, physics describes relationships and structures and behaviors. And then it stops. What the stuff actually is underneath all the equations, physics is silent. And here's the devastating implication. Maybe what the stuff is experience. Maybe the fire in the equations, the thing that makes the mathematical relationships real rather than just abstract structures floating in Platonic space, is consciousness itself. Maybe, as Kastrup argues, what we call the physical world is the external face of an inner reality. And maybe that inner reality is the only thing any of us has ever actually encountered directly. Think about it. What do you know for certain? I don't mean what do you believe. I don't mean what science tells you. I mean, what do you know with absolute, unshakable certainty? You know that you are having an experience right now. You know that there is something it is like to be you, hearing these words, in this moment. You might be wrong about everything else. You might be a brain in a vat. The universe might be a simulation. Other people might be philosophical zombies with no inner life. But the one thing you cannot doubt, the one thing that is immune to every skeptical argument ever devised, is that you are conscious, that there is experience happening. Descartes was wrong about almost everything, but he was right about this. Cogito ergo sum. I think, therefore I am. Or better, I experience, therefore something exists. And here's the paradox, the deep structural paradox that I think is the actual point of everything we've talked about today. The one thing you know most certainly to be real, your own inner experience, is the one thing science treats as most in need of explanation. It's the one thing science struggles hardest to account for. It's the one thing that falls through the gap that Galileo opened 400 years ago. Science doesn't have a soul problem. Science has a self problem. The instrument can't see itself. Now, I need to be honest with you. I don't know the answer. I genuinely don't. I don't know if Kastrup is right that consciousness is fundamental. I don't know if IIT's math will eventually pan out. I don't know if terminal lucidity is evidence of the brain's hidden resilience or evidence of something far stranger. I don't even know if the hard problem is truly hard, or if we'll look back in 100 years and wonder what the fuss was about. The way we look back at vitalism, the old belief that living things were animated by a special life force that turned out to be just chemistry. Maybe consciousness will go the same way. Maybe it's just neurons. Maybe the explanatory gap will close, and we'll understand exactly how and why 3 pounds of wet tissue produce the experience of seeing a sunset. But here's what I do know, and what I think is genuinely important. As of right now, in 2026, the question is open. Not open in the way that is there life on Mars is open, where we're just waiting for more data. Open in a deeper, more structural way. Open in the way that the foundations are uncertain. The most informed, most intelligent, most rigorous people who study this, Koch, Chalmers, Tononi, Kastrup, Goff, Hossenfelder, Pollan in his own way, disagree not just about the answer, but about what kind of answer is even possible. And the direction of the disagreement has shifted. 20 years ago, the serious money was on physicalism. The brain generates consciousness. End of story. Give us enough computing power and we'll explain it. Today, the most interesting work in the field is happening at the margins of that consensus. Serious scientists, published, credentialed, peer-reviewed, are entertaining ideas that would have been academic poison a generation ago. Panpsychism, idealism, strong emergence, fundamental consciousness. Not as faith, not as wishful thinking, but as hypotheses that might actually do a better job of accounting for the evidence than the standard story. And terminal lucidity sits right at the heart of it. Because it's not a philosophical thought experiment. It's not an argument about qualia or zombie worlds or Mary's room. It's data. It's a dying woman sitting up in bed after years of silence and calling her daughter by name. And it demands an explanation. And the explanation has to be more than brains are complicated. I want to end with something quiet. There's a sculpture outside the British Library in London. It's 12 feet tall, bronze, bolted together at the joints so you can see the seams. It depicts Isaac Newton, hunched over, naked, drawing geometric figures on a scroll with a compass. His eyes are copied from Michelangelo's David, but he's not looking outward. He's not gazing at the stars. he's staring down at his diagrams. The sculpture was made by Edoardo Paolozzi, and it's based on a print by William Blake from 1795. Blake hated Newton. He thought that reducing nature to mathematics was a form of spiritual blindness, a man so focused on measuring the universe that he couldn't see it. Blake's original title was Newton, Personification of Man Limited by Reason. The scientist sits at the bottom of the ocean, surrounded by beauty, and sees nothing but his compass and his equations. I used to think Blake was wrong. Science has given us more wonder, more awe, more genuine understanding of the universe than any mystical tradition ever could. I still believe that. But now I'm not sure Blake was entirely wrong either. Maybe the sculpture isn't just an insult. Maybe it's a warning. A warning that the most powerful instrument we have ever built for understanding reality has a blind spot. A structural blind spot, drilled into its foundations 400 years ago by a genius who needed to simplify the world in order to measure it. And the blind spot is not some distant galaxy or some particle too small to detect. The blind spot is the one thing that's looking through the instrument. You. And maybe that's what a soul is. Not a ghost in the machine, not an invisible substance hovering above the brain, but the one piece of reality that is real beyond all doubt, that no equation has ever captured, that no brain scan has ever seen, and that is, somehow, reading meaning into these words right now. Science can't prove you have one. It also can't prove you don't.